Good morning, everybody. Welcome to the first of two sessions that we're holding to celebrate the work of the summer scholars who've been working hard for nearly 2 months now in some cases. I would like to start by acknowledging the traditional owners of the land on which we're located here, the Wurundjeri people of the Kulin Nation, and pay my respect to traditional elders and knowledge holders. The format for today, each supervisor is going to introduce each student. So I'll call on Meredith to introduce Will.
Hi, everyone. My great pleasure to introduce to Mr. Will Smith. Even the very famous Will Smith. Will's one of my two honour students from last year, also Laura Abraham, who's here as well. Will and Laura were sharing a scholarship together, and for various reasons, Laura's stepped back from that for now, but this work, and as Will will tell you, is very much both of their work, and Will's taken a step up on the scholarship to reanalyse some of the data, to look at a second session of data that we didn't report in the honours thesis, and to dig a little bit deeper into it, and I hope you find it really interesting. He's a wonderful student, and so is Laura, and we had a really fabulous time last year, but also very stressful, and I'm still very grateful to them for putting up with me and the process, but I think it was worth it. Okay.
Thanks, Meredith. Yeah, it was quite a stressful year, but I'm very glad I did it. I'm also very glad I'm here today presenting, so thank you for everyone for coming. So I'll start off by saying my name is Will, and I'm a Wiradjuri and Wamba man, and also some English heritage as well. Born and raised here in Australia on Boonwurrung country in the southeast of Victoria. So today I'll run you through what I was up to, what I got up to during the Complex Human Data Hub, some internship over the month and a half. But yeah, as Meredith mentioned, it's worth noting that most of the work was completed last year during my honours project, which was supervised by Meredith with wonderful support from Andrew, Wang and Laura as well. Yeah, so I want to just give a huge appreciation to Laura, Meredith and Andrew of the year, because it was quite a challenging year, but I'm very glad I did it with them. And obviously, as mentioned by Meredith, last year I analysed the first session, but this summer internship I had the opportunity to analyse some of the second session data because I wanted to delve a little bit deeper into some of that follow-up stuff, but also into the story of the lag conditional response probabilities, which for some of you might know in the crowd, but I'll get to that later in the talk. But the title for this presentation is Locatedness during Incidental Learning Enhances Spatial Organisation of Free Recall. And then I have the application of an Aboriginal memory framework. Or in simpler terms, for those in the audience, an Aboriginal memory method for learning of facts using location to connect information. Before I do get into my presentation, I'd also like to begin by acknowledging the traditional lands that we're meeting on today, and that's the Wurundjeri people, Wurundjeri people of the Kulin Nations. I want to pay my respects to the elders past and present and thank them for sharing the stories and experiences that formed the basis of our research method. Finally, as we meet here at Melbourne Connect, if you haven't had a chance to read each of the laneways downstairs, I would strongly recommend you do so that connect to the central oculus, because each of the laneways has speaks to the continuing legacy and identity of Wurrung people and talks about the possibility to search, speak, listen, and come together. So if you get a chance, maybe after this talk, go down there and just check those out. And I'd also like to thank Dr. Shawana Andrews for her work in constructing, in combination with Wurundjeri elders, the Bill Blair's walk and allowing us to use this for our research endeavours. Okay, so the broad question we asked at the start of last year's honours thesis was, how do humans learn and recall semantic knowledge or information? Since the invention of writing, societies have relied heavily on reading and storing information on books and computers. Some argue that writing and technological storage has replaced some of that biological ability to encode, store, and retrieve facts about the world. But then we asked, how do oral cultures do this without a written language? So to answer this, we turned to the oldest continuing living culture, the Aboriginal people of what is now called Australia. Aboriginal people across Australia survived for over 50,000 years without a written alphabetic language to transmit some of that information. Instead, they used and relied on stories, which were typically sung narratives, and they've been able to, are now referred to as songlines, and they've been able to transmit information with fidelity for thousands of generations. So the effectiveness of songlines prompted us to investigate whether an Aboriginal memory framework, or the AMF, could help us understand how to enhance that process of encoding, storing, and retrieving large amounts of semantic information. So the AMF is a framework that we have been developing alongside Dr. Simon De Deyne, and also been inspired by related works from Mark O'Neill and Lynn Kelly. And it's informed by multiple memory modalities across mainland Australia, so a lot of Aboriginal languages, and places this concept of locatedness as the overarching principle of the framework. The AMF argues that the knower is always located in a space or a place, and that the stories are transmitted and they're learned that they're profoundly place-based and correspond to real landscapes on country. So locatedness is argued to serve as this spatial scaffold around knowledge, and embedded knowledge is situated on that landscape within country. There are also 5 other elements that are quite important that help sort of, improve that encoding and recall. But for the purpose of my thesis and also for the talk today, we just focused on locatedness due to that overarching role that it had. As some of you might know, there's a similar method in the Western literature that some Greek and Roman orators used to leverage back in 2,000 years ago. And they use this method of loci to recall epic poems and large speeches. The strategy is referred to as method of loci, or MOL, and it's described as an imagined navigation of familiar landscapes, such as your home or your route to work. And then you place objects to be remembered at spatial locations on that route or in your house. Then one re-navigates that space and then picks up the item, and you sort of can imagine how that process works. And they use those locations as cues for later recall. But some lab studies have shown no association between that spatial navigation component of the method of loci and the ability to encode word lists. Instead, they argue that it's a technique that argues that mostly leverages temporality and mental imagery instead of that spatial element. But other research of neuroimaging studies has shown of memory champions, particularly who use the method of loci, the ability to, one, recall large amounts of information, but particular brain areas such as the hippocampus, which is somewhat responsible for that visuospatial and navigational component. They light up in these MRI studies as well. So we argued and we sort of came to the conclusion that what might explain some of these contradictory findings is that the laboratory studies might not be leveraging this spatial scaffold with spatial navigation component as much and minimizing that component. This is a quick little rundown of some of the Western memory literature as well. So this is the contextual binding theory. In quite simple terms, it says that to remember information, we must link that information to a spatio-temporal context. This process is called spatio-temporal binding. Basically, when you make a context more distinct, you can do that by changing the time and the space. You're able to connect information to those contexts better. And this also allows for that sort of stronger context reinstatement later during recall. But the real reason why we wanted to look at this and use this theory is that it allows us to maybe explain some of the efficacy of that binding component that is we see in the AMF. It also gives us some methodologies to analyze the recall output via these lag CRPs in both the temporal and spatial domains. It also allows us to visualize whether or not there is an enhancement of this organization and whether that's provided by a spatial scaffold. And then also gives us the opportunity to test some of those AMF hypotheses. In this way, we're trying to have this two-way conversation between Aboriginal ways of knowing and doing and contemporary Western cognitive methodologies. So what are these lag conditional response probabilities? Basically, they express a likelihood of a recall of an item from position I, which is followed by I plus lag. It's quite complicated, but for example, you might recall with a fourth word on an item list, and then you might recall the fifth word afterwards. You then would score an I1 plus 1, lag plus 1. If then you remember the second word on that list, you get a -3, so lag -3. And for each of these lags, the CRP, or the conditional response probability, is calculated by dividing the number of times of the transition of that lag was made by the times that it was available to be made. So this excludes the repetitions. Basically, we can just measure the likelihood items are recalled close together in time and whether when they were heard, and whether one tends to make this forward transition or backward transition. As you can see from this graph, the first lag here is the highest probability, you've got the second one, and then actually jumps down to the -1 backwards lag. And that's sort of in that like general staircase that's pretty consistent throughout the literature. I'll quickly run through just some previous research. So this mob, Diamond and Levine, investigated the free recall dynamics of an auditory guided walking tour. And basically they found a similar pattern in a larger, I guess, narrative-based, instead of a word list. So basically they showed that the recall was organized in a way that was consistent with these temporal contiguity effects, this consistency to recall when in order, but also with a forward moving bias. They also showed that the organization of recall was positively associated with a more detailed description of the episodic memory, providing some preliminary evidence that the more distinct you can create this spatial context, the better you're able to capture that episodic memory. So what did we do? The aim of our study was to test whether free recall of semantic facts from a narrative was enhanced by this spatial context. So we operationalized locatedness to see whether the AMF would give us ability to recall more information when we walked and learned the narrative, as opposed to being in the classroom. The classroom group just saw some slides in a PowerPoint, and I'll get to that in a moment. So we had 91 participants who learned Bill Blair's Walk, which is a narrative expository text, which has about 10 themes with about 180 words. After applying a range of exclusions, such as prior experience with the walk, some saving issues, not coming back for the second follow-up session, we had about 60 left, which gave us pretty good numbers for both groups. So we had 30 in each group, 30 for the walking group and 30 for the classroom group. And then we tried to do our best to match conditions for the time intervals that took to walk the narrative. So in the classroom, we had each of the time intervals between that would help us control for that time aspect as well. This slide is just a quick slide about what the classroom group saw. So we would have A, B, and C oscillating, and then we'd land on B, and then the narrator would then talk about the narrative that was at that theme, basically trying to give them approximately 180 view of like that perspective. This is the narrative basically cut up into the segments we called idea units. Basically, an idea unit was a single factual description. There was 98 of them, about 10 for each locus. And these were used to provide the basis for calculating the temporal distances between each of the words and the thematic content. Here's just an example of location 1. But as you can see, locus number 1, and then each of the idea units and the respective narrative. We also gave them a map for the walk, basically to control for the spatial understanding of the layout of the university if they weren't so familiar. And also just to make sure that they sort of work, again, control for condition similarities. We also told them that they were going to be, the memory was going to be tested, but not to try and recall the information, just to take it all in, enjoy the walk, and encode incidentally. We also use Google Earth, and this is an important point, to derive Euclidean distances between each of the locations, to compute and each of the interlocus locations as well. So not just from here to here, but from here to here and backwards. We use these to calculate the Euclidean rather than, we use the Euclidean distances as opposed to the path distances, because we're trying to disaggregate this spatial distance from the temporal or ordinal distances between each locus, trying to sort of detach time and space, if that makes sense. And this process allowed us to determine the extent to which, potentially the extent to which allocentric spatial representations may be helping organize and guide some of that memory recall. So I'll quickly run through what they did. They basically went to a computer lab. They were asked to recall as many facts as possible, typing each little thing that they could recall from the narrative, the first thing that came to their mind, just in the order. They press enter, go through, have 15 minutes to do this. Then they did a location reconstruction task, so basically ordering of each of the locations in the order that they remembered seeing them. I also should mention that participants also did a source memory task. So they were asked to determine whether they heard a word at a specific location. But my honours colleague is probably a bit more equipped to discuss that, and for the in interest of time, I won't go into it. But the reason why I mention it is because it meant that for the second follow-up session, they heard parts of the narrative for a second time. So they heard the narrative, did the free recall, then did the source memory where they heard a word, and that could have influenced in some way the second session, hearing some of those words again. So the way we coded this was quite different to what you do with a word list. We try to match the output on the right there to each of the ID units. So for example, this one here, they use gum trees to make canoes. It's quite similar to this ID unit. But if it was more general, like gum trees outside the oval, we just gave them the general theme of this locus. It's quite broad. We understand they're talking about this locus, but we couldn't pinpoint exactly where it was. There's a few of them, as you can see, more distinct ID units plus some general ones there as well. So the fun stuff, what were our hypotheses? So the working group, we hypothesized that the working group would recall a larger number of narrative facts. So there's a distinct ID unit, the specific ones, plus the locus ones. We also hypothesized that the working group would have a higher average location reconstruction score. This is basically just trying to determine if they had a better spatial scaffold. We also hypothesized that the working group would exhibit the stronger temporal organization of free recall output, so evident in those larger, more steeper curves with the temporal lags, and also with a stronger forward bias. And then the final one was that we would exhibit a stronger spatial organization of free recall, exhibit in a similar spatial lag CRP. So what do we find? So we found for hypothesis 1, no significant difference between each of the groups, nor was there a difference between each of the groups in the different sessions. So this indicated to us that both groups are recalling roughly the same number of facts from the narrative. We had about 12 to 15 things that were ID units and about 5 to 8 things that were locus units. So about 20 things all up, which is quite small, but again, they're pretty consistent for both groups and across time. I originally just analyzed the ID units in my thesis, but I chose, and we discussed, to maybe include some of the locus units because we thought it might help get a better understanding as to what maybe they're also capturing in those general senses as well. But again, that was insignificant. This is insignificant. So there was no clear difference in whether or not they recalled more. And we can discuss maybe some of the interesting things about that in a moment. But regarding the performance on the location reconstruction task, we did find a significant difference with the effect of group and session being significant there. So you can see with the graphs, the working group had a higher location reconstruction score of 8.3 compared to 7.6. So quite a small difference, but significant. And then in the second session, we had the average score being for 8.1 compared to 7.6. So that's 8.1 out of 10 correct. Probably worth mentioning that this is still quite a coarse view of the location reconstruction task. We did tentatively look at some other versions of how we could analyze this. But for the purpose of this talk, this is probably the best thing we've got so far. But our interpretation of this is that, being located, doing the walk itself, provides the working group with a stronger spatial scaffold. Basically this allows the working group to have a better ability to reconstruct the order of the spatial context. And it's maintained over time and sort of dwindles, unfortunately, in the classroom group. Here's some of the juicy stuff for the hypothesis 3. Which was whether the working group would have a better or stronger temporal organization. We didn't find no significant evidence to support that hypothesis. They seem to be quite similar, as you can see. I mean, the graph's quite small, and unfortunately, the colors are a bit tricky to view here, but they're quite similar graphs. There was the effect of lag in session was significant, but basically that means that each lag was different from another lag, and that the sessions, the conditional responsibility weren't as pronounced in the second session. We also see a forward-moving bias pretty consistent with the literature. So we're pretty happy to see this be replicated again in sort of a larger narrative base as opposed to just word lists. But the finding of no group effect and the interaction with no group suggests that both the groups are showing this similar temporal free recall. And this is just the same analysis, but with the backward transition. Again, similar story. They're pretty identical. There's a higher lag -1, and then it sort of dwindles off, as you can see there visually. But here's the fun stuff. I'm biased, but this is fun. This is hypothesis 4. This was the working group. Hypothesis 4 was that the working group would exhibit a stronger spatial organization of free recall output in the spatial lag CRP. This graph, I need to probably explain a bit more, is quite different to the standard temporal lags. So you can't typically move backward in space. So what we did was we binned each of the lags to be, and I've mentioned that they're near and far, to be what was the first couple nearest loci, and it can be ordinarily the last loci or the first loci or the one next to it, and the last one, the fifth one, is technically the furthest away that you could possibly jump to. In Euclidean distance, yeah, thanks Meredith for clarifying. But here we can see that there's a significant difference in effects of lag and group times lag. And some of the post hoc home corrected t-test revealed that at time 1, so lag +1 here, was significantly different from lag +3, suggesting that the walking group tended to make spatial transitions between the ID nearest to locations more than they did to the furthest locations. So our interpretation of this finding is that the walking group made recall transitions to the nearest locations with the ID units, whilst the classroom group did not. This is suggesting that even with incidental one-shot learning a spatial context, one can organize their recall output of facts from the narrative in a spatial way, Euclidean spatial way. So the results in a nutshell, really quickly, we found no group differences between the amount of facts recalled. Which found some evidence that there's a better spatial scaffold for the order location order reconstruction. Temporal organization seems to be pretty similar across both groups. However, we did find this effect of spatial organization with the group having a tendency to make those shorter spatial transitions between items in the recall. And just briefly, I wanted to make some quite short reflections on just this internship program as a whole. I just wanted to thank everyone for coming. Firstly, it's a really great crowd. I'm sure there's plenty online as well. But yeah, just wanted to thank all the staff, the PhD students, and all the other members of the summer internship, just for all the terrific conversations and experiences I had just in the last sort of month and a half. I really felt like we were all working for this larger goal, I guess, for like understanding what is the human mind and the complexities of it in this cognitive way. And some of the best moments I really do think were just yarning with people on the 8th floor, grabbing a coffee with people, and just being a part of this program. So thanks again for everyone for listening, and hopefully you have some questions, but I know I've gone well over time, so feel free to chat me up if you need, but yeah, thank you. Sure.
Question with us to the working group.
Mm-hmm.
Because I wonder whether the lack of difference between the classroom and the working group could be maybe related to the working group maybe not focusing as much as the classroom. Because I mean, you could argue that people also don't focus in the classroom, but I guess you're a bit more primed. You don't have as much distractions going on.
Yeah.
Was there anything that kind of controlled people's focus as they were walking around? Like, were they walking together in a group? Were they walking by themselves? Because I can imagine if they're walking by themselves, they're on their phone, they're doing something else, but they're listening. They're probably not necessarily paying as much attention as if they were fully focusing on it.
Yeah, there's a lot of obviously facts that left out of the methodology. It's quite a long talk regardless, but basically we had them go in groups. So Laura and I took groups of between 3 and 4 people to sometimes 10 to 12 people. And we had them pretty engaged, but we couldn't control for some of that distraction. There was occasionally like trucks moving and people constructing, doing tons of things. I fell over once. There was a recall. Someone actually said that. So things happen during the walk that you can't control. But what we did find interesting, and we didn't control for that in the classroom, right? Like we don't want to have banging and crashing in the classroom. What we did find that was interesting, and what I want to discuss, is that the levels of ID unit recall and also just factual narrative were quite similar. So we don't see that distraction element playing out as much as we thought it would. We obviously predicted that it would be higher, but the fact that they're equal is actually quite interesting, that they weren't as distracted as we thought. Obviously, there's the inherent condition you have being in the classroom. You're more focused, you're more engaged. You did have, I guess, people looking at you more often, people not dawdling around. But again, that finding that they're not recalling things less than is quite interesting, and probably means they're not that distracted. Hope that answers your question, but yeah, we couldn't control for some of that noise in the class. We do hope to have a potential control group where we have just listening to the walk, as opposed to having any of the distractions, and we might see whether or not that we predicted probably won't have as much recall at all. Actually, you might find yourself being distracted. I mean, we get distracted over everything, but we'll have to wait and see how that goes. We're hoping to do that probably this year. Yep.
So I would have thought that the Euclidean distances and the path distances would be very highly correlated.
Yep.
And so I'm trying to make sense of that last graph to
Sure.
given you got, you know, quite strong CRPs
Mhm.
for, you know, in the previous ones and also for the working group. Just can't quite make sense of how's it possible for that for the classroom group to be so flat there.
The classroom group to be flat with the Euclidean distances.
Yeah, because path distances, right? So they're not the same thing, but they still should be highly correlated, right? Because if you're close,
0.3, so they were correlated about 0.3.
Oh, really? Okay.
Yeah.
So the thing is naturally with some of the path distances, this is probably tricky as well, is that there's different routes throughout the university that you can take to get to each of the loci, if that makes sense. So we had one distinct route where you go round in sort of a loop. But what we tried to do with Euclideans was have, if you were at 0.5, you could go to point, like, as Euclidean exists, you go straight to 10, straight to 6 or 5 or 4. Whereas the path distance, I guess, is quite different. It could be different order. Does that make sense? So naturally there would be.
so it's a loop, you're saying. So
It was but not really a loop. It sort of came back and looped around. So like, yeah, go to the map.
So you loop back on yourself for
Not every so often, sort of.
oval.
Yeah, that one.
Sort of come around and then go back into here. So what I meant by the Euclidean, so we would calculate from here to here to here to here. So this path distance might be correlated with that Euclidean. But you could also imagine someone walking around here as well. And of course, if they're familiar with the campus, they might take a different route in their mind. So the Euclidean was an attempt to try and detach from that temporal ordering, but also from like the uniqueness of the path distances that each individual might have. So we're trying to see if just naturally their brain was associating things close in space, regardless of the path distance they would take.
Like the 6 to 7, they're next to each other temporally, but they're one of the longest distances.
Oh, these two?
For example. So the 6 and 7 follow each other temporally in the narrative, but there is quite a long distance to traverse as the crow flies. Locus 3 is not right from both sides. So the correlation between the two is about 0.3.
But you can also imagine if you had, let's say, this Euclidean from there to there, the path distance is like this. So that it's quite a larger path than it would be just a Euclidean. Hope that sort of helps the explanation. Go ahead. Yeah.
Maybe this was part of the presentation I missed at the time. Did the participants during the walk at any time know exactly where they were, like relative to kind of the map and the campus? What was their understanding?
So what we would do during each of the locations, we'd take them there and we'd say, this is the Baldwin Spencer building. Have a look at it on your map. And so we'd refer to them, okay, here you are on your map. You'd find the place on the map, give them about 5 to 10 seconds to just like orient themselves where they've gone, and the same in the classroom as well. So we'd say, imagine you've walked from the Oval down to the Baldwin Spencer building, giving them the same amount of time to look at the map to see if they could match it.
And on the map, they saw all the points on the tour.
This is the same map given to both groups. Yeah. So this is the same map given to both groups, both the walk and the classroom group. And
So they have the opportunity to kind of relatively go to different points.
Yeah.
Visually.
Yeah. So we gave them a couple of seconds, like, here you are at the Oval. You just walk from the Redmond Barrett Courtyard. And then after that, we'd say, here you are, the Baldwin Spencer builder. You just walk from the Oval, giving them time to try and hopefully, if they're familiar with the campus, maybe walk in their mind, or also just measure it on the map. No worries. Cool. Awesome. Thanks, everyone. I appreciate it. If you have more questions, I'll be around a little bit after. Thanks.
Or can I talk into this weird microphone? This is a real pleasure. This is a project that was born out of, what shall we put it, a vigorous discussion with Andy. Some might call it a disagreement even. And it's something that I didn't have time to do myself, and I am so grateful that Daz actually did this. And I'm not going to steal his thunder by explaining what the project is. I just want to point out one thing. The project involved a massive amount of work on Daz's part, going through as he will explain, 1,000, I think it's 1,000, short responses and thinking deeply about them and coding them up in multiple ways. And this would have driven me absolutely nuts had I wanted to do this. And I don't think I could have paid anyone. So for that alone, I'm very, very grateful. And Daz has done some sterling work. And I'm not stealing his thunder. Introduce it. Thank you.
Hello. Thank you for attending the presentation. So let's talk about, is Amtrak still usable? Now, here's some background. That's how the project got started. A while ago, Piers noticed some duplicate responses in his Amtrak data, and he was like, that contaminates the data and invalidates his analysis plan. He was not happy about this, hence the what is it, argument. So he also was unsatisfied with the with his colleagues' advice to just use Flickr, and he said no, and he came up with a novel way to statistically estimate the proportion of frauds. That's based on signal detection theory. So he needed what we call a human open-ended response detector. And he found one. And he set off to avenge his invalidated stats analysis. So now back to maybe a bit more seriousness. There have been studies about Amtrak's issues, but the previous main focus was on data quality, defined over dimensions such as attention, comprehension, honesty, this sort of thing. A couple studies did look at fraud, and what they propose is, first, IP filtering is not enough to defend against fraud because IP is just not designed for that. And the slightly earlier study, Chandler and Paolani, they observed that there are VPN usage on Amtrak, and that is observational. So that leaves us with the gaps. First is that the fraud issue really should be addressed prior to studying data quality, because if a study data to study data quality implies that we're working with data. But if someone is doing the survey multiple times, that means they're aiming for $1 per hour sort of thing. So what they give is not data. The frauds need to be taken out before data quality is a thing. The second gap is then that there has never been a rigorous estimate of the proportion of fraud on survey platforms. So that's what we want to find out. We want to find out the proportion of frauds across a few survey platforms. And to do that is basically to compare the effectiveness of different survey platform filters. By the way, the frauds we define here as duplicates, GPT-generated responses, and responses that just copied from the internet that we can identify as source. So by doing the above, we can find out which platforms to avoid. And this is what we did. We did a quadric survey across 5 conditions. The survey began with a bot check to select a specific letter, in our case, the 6th letter from a drop-down menu of O alphabet. So a bot should have a low chance of getting through. Failing this bot check question terminates the whole thing, and the participant will be kicked out. And that's the 3 open-ended questions we had. It asks you, ask people to talk about their interest with regard to internet usage, their fitness choice, or their music preferences. The blue parts are areas of topic, and the black part actually are suggestions. We added that to the question to suggest what people could talk about. This is because people and GPT take these kind of suggestions really differently. So this type of question helps us with the GPT part. And then that's the 4 platform blocks with 200 people each. First is MTurk Raw. That's just MTurk as is. MTurk Andy is a previous effort from Andy, Kate Reynolds, Thomas Nguyen, and Andrew Wang. They came up with this novel questions to pre-screening, like screening questions, logical ones, grammar ones, open-ended ones, and they pre-screened a participant pool on MTurk. And the third condition is cloud research. They claim to have, well, they have demographic filtering, fraud detection, and what they call sentry vetting tool, which is IP filtering. And then prolific, the last platform condition. They filter workers upon registration. So to register on Prolific, you need to provide email, phone number, photo ID, PayPal account. And they also do a continued account checks after you begin with them in the form of superhero related questions. So that's the 4 platform conditions. Then we had also a constructed block. This is to verify the rates of the horde. 1/3 of this is duplicate responses written by a human, Piers, paraphrased by GPT. So I wouldn't pick up the Piersness. And then another third is just plain GPT responses. The last third is known human responses. And you may remember this, we send them out before Christmas. They are good data. We know they're from basically the hub and some of the known people. So once we have all the data across 5 conditions, that is Piers told you 1,000, not quite. Well, more than 1,000. So we had all the data. Piers blended all response across 5 conditions for question 1 together, and then for question 2, and then question 3. So that's 3,000. And the horde received the 3 data set, each contain 1,000 responses to the same question. The horde read them and decided whether one was a duplicate of another response, whether one was generated by GPT, whether one was copied from the internet. That's like just to show how it works. Once this the reason we did it this way, to blend everything together, is to be as rigorous as possible. So the horde didn't know how many of each type there would be. So I didn't know the base rate. Basically to blindfold me as best as we can. And then this is what we consider a hit. All data processing done, we de-randomize the data, put everything back together so we know the ID of each participant. For example, DAS, all 3 responses from DAS weren't labeled as any type of fraud. So they're good responses, they're usable. 2 of Piers's response were labeled. We're using example here. Like we wouldn't know the identity, but just for ease of communication. 2 of Piers's responses were labeled as copied, but the last one weren't. Because they didn't line up, that's not a hit. Vader, on the other hand, all 3 were GPT. That's not as surprising, it's Vader. So that lined up, that's a hit. We think it's a fraud. But more importantly, the reason for Java there, it is the same. When they line up, it's considered a hit, it's considered fraud. But what makes the duplicate part of the study more rigorous than the other parts is that we must label duplicates, but we also have to say which duplicate group does one belong to. So that makes the analysis more like stronger. Then basically overall, we're being quite conservative with how we identify fraud. And in addition, as a secondary goal, secondary analysis, we use GPT to rate all responses across 5 dimensions. It's to rate all responses consistently. That's why we use GPT. And it's to rate them on fluency, grammar level, depth of thoughts, native tonality, and uniqueness. And they're combined into a writing quality score. This definition of writing quality is arbitrary because it really hasn't been done before. So it's a secondary goal. For analyses, we did a Monte Carlo simulation to estimate the proportion of fraud. Also a Fisher exact test based on my rates. And the below is my rates. For duplicates, I got 100% hit rate and 0% false positive. For ChatGPT, 64% hit. I'm being quite conservative, but I didn't make mistakes. So there's 0% false positive. Now is the results. The main finding, percentages instead of proportions, just so it's clearer. Percentages of duplicates. For Amtech Raw, we have 37.5% duplicates. Cloud Research had 2.5%. Amtech, Andy, pre-screen, and Prolific are good. The superscript means 1 means statistically significant under both the Monte Carlo simulation and the Fisher exact test. 2 means not statistically significant under the Fisher exact test. Same goes here. The percentages of GPT, Amtech Raw had 19% GPT. Amtech Andy had 1%. Cloud Research had 6% GPT. And Prolific at 2%. Then finally, the percentage of copied responses. Amtech Raw 32.5%. Cloud Research had 1%. Amtech Andy and Prolific are good again. So that's great. Now, usable percentages. Some of these fraud method overlap. So for Amtech Raw, our data ended up with 37.5% usable. And Cloud Research, 93% usable. Amtech Andy and Prolific are good. And at the bottom are the writing quality scores from GPT, average for each platform.
For the usable data.
For the usable data, the usable proportion. And the Amtech Raw is somewhat lower, slightly lower than the other 3, and the other 3 are quite consistent, or around 4.1. That's it. That's then the take-home message. Amtech is not usable. It's no longer usable. And don't use Cloud Research either. Andy's pre-screening filter and Prolific's are good. And I really want to thank Piers and Andy for guidance on the project. And I want to thank Andrew Wang, Keith Ransom, and Manika Lester and Yvonne So for helping out. And lastly, to thank Charles to make Easter egg guest appearance on the second slide. Maybe you don't remember that little detail. That's all good. But yeah, that's it. Thank you very much. All right. Questions.
I just want to make a point.
So your first mTalk raw, there is actually some data quality control. There's a standard one, 100. Each person has to have done 100 hits and got up to 95% positive. So we're using the standard stuff you find in the literature. It's not actual raw.
I got a couple of quick questions. Just a fun one. Do you know if ChatGPT rated its own writing quality high? Did you check?
Well, it's the usable proportion, so
Yeah, I just thought it would be funny with those writing quality. So that doesn't actually.
it potentially could be the case. If that's the case, that's scary.
I know that on Prolific you can choose where your participants from and filter for like English fluency and that kind of thing. Did you do anything like that?
Prolific, we did not.
We did choose where they're from.
Right.
So I thought it was the USA. I didn't get it, and of course they are. Yeah, I think we chose them to be those.
And is that a thing that you also do on MECTech, or?
I'm trying to remember, we matched it as much as we possibly could. You can't completely match it, but as much as we could.
Okay, yeah, thank you. That's it.
Anything else?
I have one question just on the writing quality.
Yep.
So that 3.8C, that's usable good responses.
Mm.
And did you check whether there's they're different at all? I mean, these are pretty similar, but like is that one different from any of the other ones? Because I'm assuming that's.
I'm basically the data processing tool of the project, and that's what I'm given. But we didn't do a formal analysis on the writing quality because it's not defined rigorously. And all the GPT processing, I think it's just a consistent ruler against all responses, all usable responses. So
I thought we did actually. I thought we did the test in this.
well, from the number,
3.86 from the other side, so
right.
The reason why I asked is because like so even I mean not usable, but even have the good responses, the writing quality things.
That's good. Which probably means when we're being very conservative, so a lot of those so-called good responses aren't actually that good. Again,
So yeah, there are, because I was blindfolded, so I didn't know which response is from where, but there are responses either very, very short, broken English, or just, it seems like randomized language, but I have no way to label them either as copied, because they're not, and it doesn't seem like GPT, and they're not duplicate, but it's very bad responses. Just there's no way to consider them as fraud.
Yeah.
And they are left in the data. I think that reflects a little bit here.
I have a question. Okay, I'll go first. Sorry. No, I was just going to ask because this study requires participants to write the answers. So that suggests that MTech probably not that good for that. But what about if the study was just multiple choice? They just had to select things. They didn't actually have to write something.
I think.
Yeah, but I'm saying in terms of like, the quality of data, even if we ignore like the fraud issue, which is.
I want to answer those yours.
I think what this reflects is the underlying motivation and behavior of the participant pool of each platform. So if it's a survey, we just have no way to identify it, maybe, but people would be streamlining and maximizing their dollar per hour, perhaps. So we just can't identify it. Doing open-ended responses is so we could try to identify that and can infer the sort of proportion back to other data. And it's not looking good for them.
And it keeps raising up.
Okay, so
Andy,
we'll check what Andy says and then.
View?
Right, yeah,
Okay.
sorry, I was dithering about I was just,
And
yep, sorry, I was just dithering about whether to say something, but I wanted to sort of, this is very cool, but sort of on the last bit of the discussion, I wanted to note, so this previous study that Daz was referring to of ours, we did look a lot more of these other kinds of data quality measures, and you see the difference, the exact same differences here between mTurk raw and these other ones on those as well, with mTurk raw being much worse, cloud research second, and the other two better. And I also wanted to note that I had a little an unofficial writing quality measure, which I think, you know, also parallels your findings very well, Daz. So, and I had the same anecdotal thing, which is there's just a lot of like sentence fragments and just really, which I rated it on a 1 to 5 scale, and I put it as 1. So, yeah. And by the way, GPT had the ones that I didn't know were GPT had a higher writing quality generally than the people that yeah, mainly because there was not this low end of people's writing that I thought was people, but not GPT. But anyways, it's all very consistent. So that's pretty cool. Thanks.
Awesome. Yeah. Thank you.
Hi everyone, the next talk is by Enzo. He's going to talk about semantic role labeling. This is a project that was also co-supervised by Andrew. Thank you, Andrew. So Enzo is very interested in, I guess, the novel capabilities that are afforded by things like GPT-4 and so forth. So we thought this is an excellent application domain. Yeah, so Enzo has been working on this quite independently, so he should get some credit for that. And he also had some really great ideas during the internship. It was great working with Enzo.
Thank you.
I really enjoyed it. Obviously, this is like, it's a new project that we started doing, and there's still a lot of follow-up work, so maybe let's go at some point. So yeah. I'm really curious to hear what you have to say. Thank you.
Thanks, Simon. Hey, everyone. I'm Simon's intern, and this has been really exciting for me because it's my first research experience. I just finished my base undergrad, so please go easy on me. So yeah, okay. So semantic role labeling. What do we mean by this? So a lot of you have probably seen this word association network from the spreading activation paper by Collins and Loftus. But the reason I bring it up is just to have a familiar graphic. So this graphic is familiar to everyone, hopefully. And what I was interested in was what these the lines between each node were represented. So do they represent the same category in the case of, say, red-orange properties like fire engine, or locations even like fire engine house or vehicle street? And so what I mean by semantic relation is the meaning relationships between these words. Okay, so sorry, how do I? Okay, cool. And so one of the most comprehensive word association networks was made by yours truly, Simon, and it consists of over 1.3 million word pairs. So each word pair is made up of a queue and a response. And so the questions that I was asking was, what kinds of relations are these, and how do we label all of these within reasonable cost and accuracy? And so here are some examples of the word pairs, and here are some possible relations we could give them. So they range from very superficial, like mere collocation, like mere co-occurrence, that is. So say in the phrase time flies when you're having fun, that's where the response flies probably comes from when they're presented time. And they can range all the way to deeper semantic relations like dove peace. That's more of a symbolic response. And one special case of these is the very last one, cultural mediation, where you need a specific cultural context to understand with that response. Yes,
Sorry,
yes.
I'm a little bit confused.
Yes.
So when you say relationships, do you mean temporal, as in you have a sentence like time and then the one word appears before the other one, or are they considered related if they both appear in the same sentence? So what is your definition of related?
So related in that the way that SWOW was created was participants were presented queue, and they were given three responses, right? So say they presented time, and they could say flies, space, and a different response. So essentially in isolation, that is. Yep. Does that answer your question? Yep. Okay, cool. All right. And so and doing so manually, well, as you can imagine, 1.3 million word pairs is a lot to manually label. And I'm sure Harrison will get into the problems doing that as well. But there's also some other factors we need to consider, like say polysemy. So words with multiple meanings represent a very unique challenge as well. So something like bank has multiple definitions. Also the inter-rater reliability. So the same word pair can be labeled as more than one relation. And as you can see, as you'll see in a bit, these can be quite arguable. And one distinction I'd like to make is that these relations can be split into two main categories. So the first one are these co-occurrence and form-based relations. Say in the word pair I spice, say someone's presented the cue ice and they responded spice. We could say that's a rhyme relation, that's where this response comes from. It could also be a common phrase, like, but the definition of what a common phrase is quite broad and maybe even all-encompassing. And so that kind of, these kinds of relations we're not particularly interested in. What we really want to get to the crux of is where the meaning lies. So, and lastly, it could be labeled as a cultural reference. So something like the hit singer-songwriter Ice Spice, or it could also be that the cultural mediation comes from the phrase ice pumpkin spice. So as you can see, where these come from is really debatable. And it really depends on the person rating the particular word pair association. So yeah, we could even label these as all of the above. Okay. So one way to facilitate this is with the use of an semantic relation ontology. So a categorization system so that individual raters are given a unique set of relations, of limited relations that they have to use for any given word pair. So it facilitates accurate and efficient labeling. And previous studies have compiled these from cognitive studies and human rater frequencies. So the ones that cropped up in previous ontologies are the ones that I myself compiled. I tried to make an ontology myself. And from 7 different ontologies, I selected labels based on how common they were between the ontologies and within the data that I'll get into later. And also whether they were informative in that otherwise badly categorized word associations were had a label that they neatly fit under. And likewise, I rejected the ones that were relatively rarer or uninformative. And so through this iterative process, I selected several labels which fell under these 5 different broader categories. So as I already said before, these shallower non-semantic form-based and co-occurrence-based relations. So we really just identify these to exclude them from our analyses. And then you've got the taxonomic relations. So say dog animal, that would be a category-based taxonomic relation. Also your more traditional sense relations like synonyms and antonyms. And for another one is entity features. So a typical feature of, say, an item, say fox, nimble, that would be an example of an entity feature. Okay, and another one is thematic and situational relations. These are quite broad and essentially they rely on the context that items appear in. Say, for example, blackboard, teacher, they appear in the same context of school, and that would be type of thematic relation. And lastly, we've got these introspection relations. So essentially, if people are given a cue, say school, a type of introspective response would be important in that they think school is important. And so these differ in their, well, how superficial they are, and to how the type of semantic relation essentially. But another problem that we faced was, how do we actually select between these? Well, one previous study actually used a directed graph to select a semantic relation. So you can see on the left, they've got the broad categories, and within those broad categories, then they split off into the individual relations. And with each node is a binary decision. And so I made one myself using the relations that I selected from those 7 ontologies. And also I adapted some to fit some of the rarer relations better. And so I made it using PureFlow. And one of the things that I tried to do with this decision tree is that those position form coherence-based relations were double-coded with the deeper semantic relations. So say a word pair like unconditional love, that would be not only a position, a collocative relation, that would also be arguably a typical property of, say, love, right? So unconditional is a property of love, but it's also a collocation because it's a common phrase, right? So doing it this way was borrowed from this previous study by Wang Chen. And also, I found that a lot of the taxonomic relations were could arguably overlap with these other categories. And so there's that potential to double code those as well. But there were several problems with this one. First of all, the ordering of the decisions was relatively arbitrary. I tried to make it such that it was the most superficial relations first, and it branched off into the deeper ones later. But again, there is no evidence to back up that this is the ideal way to do this. And so that's one problem. Another one is that some of these labels are quite controversial, and a lot of the disagreement between the raters actually come from these more controversial labels. And lastly, there's some definitional overlap between these relations. So something like function and result, they could arguably map onto the same relations. But yeah, I included them anyway because I thought they were quite informative of some of the ones I found in the data. Okay, so yeah, while it may be pretty, at the moment it's pretty useless. Okay, so now on to analyzing previous data sets. So this data set by Chen had several different languages worth of word pair associations. So I only analyzed the English one, but it did have 2.5K distinct word pairs and 2 human English coders. So Meredith and Simon were actually the coders for this one. And just one thing to note was that all the cues were nouns. And so some of these relations might be more common with noun cues than other parts of speech. But even though there was some disagreement in some of these broader categories, overall, the agreement was quite good. It was about 86%. And so that's the kind of rate of agreement we'd expect to see if we were to say use LLMs to predict these. It's the ideal benchmark we'd like to see for individual variation. Okay, so within those ones that were agreed by both coders, you can see that there's quite a broad range of different frequencies for each of these relations. So while that may not necessarily be a bad thing, some of these ones which have been coded more often than others might not be that informative. Whereas some of the rarer ones may better fit in some other categories. We don't know. It's just, yeah, I included this just because I thought it looked nice. Okay, so one way to approach labeling all those 1.3 million word pairs from SWOW is using ConceptNet or previous word relation databases, like say ConceptNet. So this image on the right, the left, sorry, is the ConceptNet page for Fox, and you can see all the different possible responses you could have to it under the relation. So location of Fox, England, Fox Hunt, and yeah, for all the different relations. So synonyms of Fox in different languages, derived terms of Fox, and yeah, so but many of these relations are form-based, which again, we don't really care about. And so when we left joined this with the word pairs with SWOW, it only covered around 10% of the relations. So that essentially gets to the motivation of using LLMs for automatic semantic role labeling. So even though previous work has shown existing has used existing databases to label SWOW, the coverage is quite low. And so LLMs represent a possible way to improve the coverage, but it is limited by the accuracy that is the human, how similar it is to human ratings, and the cost of prompting these LLMs. And so this image here just shows a general approach. So we use the LLM to label these different word pairs, and then we reiterate the ontology to work better with the LLM. Okay, and so Leah Furman is one of the people that I worked with, and she actually did a similar trial to us with her own ontology of 16 relations. She's a test set of about 1K word pairs, and you can see that the accuracy isn't very high, and some of the relations labeled by humans were vastly underrepresented. Like this is a relation wasn't very well captured by the LLMs. So I replicate that study. Sorry, that trial was on GPT-3, and I replicated it on GPT-4 with about an 8% improvement in accuracy. Okay, and so I repeated this trial with the coded pairs with Chen, the Chen dataset of that I was talking about earlier. And so this is the general prompting strategy that I used. So first, I gave it the instruction to predict the relation underlying the connection between the two the word pairs, and then I gave it the possible relations that they could possibly be with a short description. I gave it an example for each. I repeated the instructions, and then I gave it the list of word pairs. So because obviously GPT-4 has a token limit for the prompts, I did these in batches of around 50 word pairs. And so, of course, we need to measure what works best. So first of all, the overall accuracy. So the number of pairs correctly identified over the total number of pairs presented. So correctly identified meaning it matches the human raters. And second of all, the relation accuracy. So the number of pairs correctly identified within each relation over the number of pairs labeled that relation by humans. Okay, so I duplicated it with the Chen data using a 600 word pair sample from those uncontroversially labeled word pairs between the two coders. And first of all, I removed all the position form relations just because, as we've already established, we don't really care about those. And yeah, this is what I found. As for the macro relations, they labeled the word pairs quite similarly in frequency. So that's pretty good. And as for overall accuracy, it was 53%. So relative to the other trials, the one using Leah's ontology, it was actually pretty good. But it's still quite far off from the human agreement. So not bad. Within the micro relations, you can see again that some relations were underutilized by GPT, whereas some were overutilized. And this other graph shows the accuracy within the relations. So evaluations and immersions were had a 100% accuracy rate. That's pretty good. But then you remember that these are quite rare in the within the sample and overall. And yeah, I guess this is just to show we've still got a ways to go prompting LLMs. Okay, and sorry about this, but yeah, this was made like 15 minutes before my presentation block, but essentially it's a confusion matrix of all these different relations. What we'd like to see is this this diagonal line from top right to bottom left to be lit up. But yeah, that unfortunately isn't the case. You can see the relation object was very confusable with other relations. And so maybe that's one of the relations we'd like to change. Okay, so for the future, one thing we'd like to try is these ontology agnostic trials. So instead of giving it an ontology that we made up ourselves, we prompt GPT in a way that it makes its own relation labels. And so you can see here, we give it a single queue and all the responses to that queue. And we just tell it to structure the relations in a meaningful manner and provide an explanation for each grouping. And so this is what it came up with this particular queue ERC and the responses. So you can see a lot of them map onto the top-down relations, like botanical characteristics. Well, that's reminiscent of entity properties. Comparison with other trees, that's coordinates, so items within the same category. But then it also catches these cultural references, which human readers may not necessarily catch themselves. So the Q was ERC, and one of the responses was professor. Those of you who may not be familiar with the video game Pokemon may not recognize where this comes from. But one of the benefits of using LLMs is that these cultural references are captured, even if because it's not a human reader. And also, yeah, so that's one of the benefits of using LLMs. Okay, but what are the problems with this? Well, first of all, the relations that it comes up with are quite domain specific, and so it resembles frame semantics a bit more than semantic roles. And we need an automatic way of mapping these analogous relations. And also, we return to this problem of inter-rater agreement of, so for example, ERC Ash, the response Ash could either be the tree, and that would make it a same category relation, or it could also refer to the main character of the Pokemon series, Ash. And in fact, the response was given to us capitalized. So it may have well been that it was referring to the main character of the Pokemon series. So yeah, so that's something to try out in the future. And yeah, I'm sorry that my project wasn't as statistically rigorous as the ones we've seen so far. But yeah, thanks for having me, everyone. And I really enjoyed my time here.
So and results on this project. And this has been a data set that we've been collecting for some time, a couple of years, on lexical translation in different languages. And one of the things that makes this challenging is when you don't speak one of the languages that you're investigating. So this is where Harrison comes in, because he's a fluent Chinese speaker. So he really helped us out making sense of the data. And yeah, so I'll give you the floor. Andrew, do you want to add something?
Sorry, I missed.
Yes, no, it's good. So yeah, Harrison, thanks for all your effort working and coding during the internship, and take it away.
Thank you, Simon. Hi, everyone. The topic of my project is factors that predict lexical translation. So translation equivalents are largely used to investigate second language process. There are words from two different languages that share similar meaning. Words with multiple translation equivalents from another language are described as being translation ambiguous. For example, the Chinese word 桌子 can be translated to desk and chair. Having two or more of these type of translation equivalents make it a translation ambiguous word. The issue of translation ambiguity is both highly prevalent and impactful in bilingual lexical process. It's not uncommon to have translation ambiguity in words. In fact, research on different language pairs, including Japanese to Chinese, English to Spanish, or Chinese to English, have all shown high language ambiguity. Research has also shown that language ambiguity can profoundly influence the bilingual's performance in translation tasks. It was found that in this study, it was found that bilinguals recognize unambiguous words faster and more accurate than ambiguous words. Therefore, it's necessary to investigate factors that predict ambiguity. So previous studies such as Van Haven and Ted Lee have built translation norms to investigate possible factors that predict translation ambiguity. Van Haven used Chinese to English word pairs, and Ted Lee studied Malay to English pairs, both forwards and backwards, so Malay to English and English to Malay, whereas Van Haven only did Chinese to English. The word related, so the word related factors such as frequency and word concreteness, individual related factors such as language proficiency were discussed. Word frequency and concreteness are the two main factors included in the Van Haven study. Previous studies had contradicting findings in the association between frequency and ambiguity. Sen found that they had positive associations, but Pryor had negative associations. Moreover, Ted Lee suggested that frequency of backward translation, in this case, English to Malay, which is similar to Van Haven did English to Malay, was not associated with ambiguity. So frequency does not play a role. Therefore, the purpose of analysis therefore it's interesting to replicate these findings to see if that if it remains with forward translation from Chinese to English in our case. These two studies also contradicted in the effect of proficiency. Van Haven study found that second language proficiency predicts dominant score. So dominant score is the percentage is the percentage of so dominant response refers to the response produced by the majority of the participants. People with high dominant score produce more dominant response. So this means that the better you are at second language, the better you are at producing the dominant response. But this was not found in Ted Lee. Instead, they found a significant association between first language proficiency and forward translation. So the better you are at first language, you're better to translate it to second language and provide a dominant response in second language. And it's just interesting to see whether that remains in our Chinese to English pair. In addition, in both studies, no pre-process was done to exclude errors such as typo and spelling mistakes that show no actual semantic difference in lexical translation task. Therefore, a more screening scheme should be included. In the current study, we conducted a replication of the Van Haven study mainly to using English and using Chinese to English pads with more detailed data cleaning and larger vocabulary set, testing whether these results are the same with pre-processed data. And these are the two research questions. So whether word frequency and concreteness predict ambiguity, and whether whether proficiency in first and second language predict dominant translation. So in the data collection procedures, we reported participants' Lextail score as an objective measure of their language proficiency. So we used Lextail US for English and Chinese for Chinese. And frequency, we use Sublex US and Sublex Chinese. For concreteness measure, we used the data from the Bryce Barrett. And the frequency, it's worth noting that the frequency measure is a ZIFS score, which is a logarithmic scale ranking frequency from 1 to 7, 1 being the least frequent, and similar goes with the concreteness measure. But concreteness measure has the high value in concreteness measure means more abstract, which is a little different from what's used with Van Haven. We'll talk about that later. So in the first step of the data filtering, we filtered wrongly spelled data using a English dictionary based on the English spelling only. So we singled out the words that are incorrect in spelling, in English spelling only. Then we categorized these errors into typo, spelling mistakes, and morphological mistakes. Typos were then excluded from the analysis because it does not contain any information related to semantic understanding. But we had the spelling mistakes and morphology for future analysis, but not in this study. After correcting and identifying for spelling, the words were then standardized to converge similar word forms to make it easier for the dictionary to detect correct response, thereby avoiding situations such as having the word running being incorrect, but run being correct. And so that's a summary of the data. So in total, we have 198 participants. They provided around 100,000 around 100,000 words, and out of which 76.2 was correct. This was before correcting for spelling. After correcting spelling, we had more accuracy. And as you can see, the tolerance of spelling errors effectively made the ambiguity graph less steep. So you can see how it's comparable to the ones that were from Van Haven study. So that's so for the first analysis, we first conducted a Spearman's correlation between frequency and translation ambiguity. The comparison among the results in previous two studies are shown in the table here. So as we can see here, in the raw data, there's only a very small association between frequency and ambiguity. Very small, but it's a little bit better, but not too much. But it's significantly different from the Van Haven's result, and but it is similar to, but it is similar to the Ted Lee's result. And then as for the concreteness, Van Haven study, because Van Haven study used a different scale. In their scale, the concreteness, the lower the concreteness rating, the more abstract it is. So that's why theirs are negative and ours are positive. But then we can see that with the spelling corrected, the concreteness scale, the correlation became smaller. But like it demonstrates the idea that more concrete words have fewer alternative translations. In addition to this, regression analysis was conducted to see whether frequency, concreteness, and their interaction predict ambiguity. A model containing the effect of frequency only, frequency and concreteness, and frequency, concreteness, and interaction was included. The model selection procedure was shown in this table, and you can see the one with the interaction is the best model. And that's the stats for the model. And different from the Spearman's test before and what was done in Van Haven study, the frequency did not explain the variance, but concreteness explained 64% of the variance, and the interaction between frequency and concreteness explained 0.08% of 0.08 of the variance. But that while it's not a strong interaction, it does explain. It is significant. This means that the association between concreteness and ambiguity is decreased with increased frequency. So one of the reasons why it does not fit with Van Haven's study is that these data are a combination from 3 runs with different words, which means that some words were presented more than others, which could potentially affect the result. Therefore, we calculated a type token ratio, and after using the type token ratio to balance the difference in total response, the regression analysis still showed no effect for ambiguity, as you can see. But like this, it's strong. It's slightly stronger than the previous one. The difference might be due to the difference in the stimuli used in the vocabulary. So in the future studies, it is necessary to standardize norming items to separate language-specific characteristics from language universal factors. And the difference between raw data and the semantic data show a strong difference, and this might be due to the difference between the raw data and the semantic data. All right, so yeah, so basically it might be due to the small number of errors that the effect of correcting for spelling errors were not shown. So for the second hypothesis, we used the Pearson's correlation to calculate the Chinese the association. So as you can see here, again, the result is you can see from the English lexical current. The result, the association between English and between English proficiency, so second language proficiency, is not associated with them providing dominant translation. This is consistent with the Ted Lee study, and one explanation of the first language proficiency is significantly correlated with producing dominant response. One explanation of why first language proficiency might be relevant, according to Ted Lee, is that there might be a variation in first language proficiency even within the first language group, so that that lead to such significant association. So you may be born and raised in Chinese and speak Chinese, but you can still vary in your ability to speak Chinese. So the consistency in the non-significant effect of second language proficiency show that forward translation might actually be a different mechanism with backward translation. Therefore, an analysis comparing these two types of translation result is necessary to further validate this idea in Chinese-English pairs. There are, of course, a few limitations of the current study. First and the most important, the Chinese to English dictionary that used to check the correctness had poor convergence with the cues used, leading to a large number of data being omitted. So it's in our case, it's about 2/3 of the data because of the dictionary. So this can be avoided using cross-dictionary corrections or having experts in both language to identify errors. However, I was not able to conduct this within the time frame of the project. So also concreteness rating, frequency rating, and Lexatel ratings are all different across languages. This makes it more difficult to compare and find meaningful results. A standardized measuring method should be applied that remove language-specific characters. Overall, the current replication of the Van Haven study showed contradicting findings and was more consistent with the findings from Ted Lee's study in terms of the effect of word frequency and proficiency, revealing possible difference in forward and backward translation between English and Chinese, and future analysis should be done to find whether such difference stands in a study investigating both in Chinese and English pairs. That's all for my speech. Thank you for listening.
Meredith had a question now.
Oh, sorry. Yeah.
I was just interested in your thoughts on the difference between forward and backwards translation. Did you want to answer from here?
Yeah. Sure.
Back to translation, it seemed like a very important point that you made.
Yeah.
There's some theoretical models that would suggest that there should be differences.
Well,
reverse hierarchical model here. So going from your first language into your second language would go, you're essentially doing a translation. What are we doing? Back translation. How does it go? There's a model that would suggest that, and I'm wondering if you have some thoughts on it, because my thoughts are a bit vague.
Which model are you referring to?
There's a model of bilingual processing called the reverse hierarchical model.
Oh yeah, yeah. No,
Revised hierarchical.
I think I haven't had a chance to have a look at it. So. Right, but yeah, that's definitely worth having to. Right. Well, yeah.
I was wondering if you had any thoughts on. So I wasn't really sure if you considered what happens if like a word is unambiguous in Chinese but is ambiguous in English, or if it's ambiguous in both languages. If like there's a sort of problem at both ends when making a translation. Does that have any impact? Because it might explain some of the inconsistencies of other studies that were in a different language. If I don't know, maybe Chinese versus Malay, one might be less ambiguous than English, the other one might be more ambiguous than English, and there might be like an interaction there.
I think yeah, that was also part of the analysis I did, but that was not included because of the time. But yeah, it was also done in Van Haven study, and they found that it's that the difference in they weren't able to come up with a, so there was basically no association between the ambiguity, but I think that's because the scales are so vastly different, and they weren't able to provide any meaningful association.
Fair.
Yeah.
And I remember if you had a question for Enzo.
Yes.
Do you remember it?
Yes. Oh, yes, I do.
Oh, okay.
Sure.
Sorry, what's that one?
Okay. So Enzo, my question, now related back to your talk.
Yes.
Why, in a nutshell, why do you assume ChatGPT was getting it wrong? So you were comparing ChatGPT at multiple points in your talk,
Yeah,
to the correct answer. But maybe ChatGPT was more correct than the correct answer. And that's kind of
That's
what I
true.
found in some of my research.
Mm.
You have to be very careful getting a baseline. So
yes. So one of the reasons why is because some of the relations I talked about were quite broad, and so the limitations of my prompting was that I could only provide one example of each relation, and so even if multiple different types of word pairs can fit within the relation, I could only give one of those examples in the prompt. And so maybe it's not so much that the GPT was incorrect. Maybe it had to infer more based on the examples I gave it.
I see what you're saying.
Do you want any more information to clarify that? Sorry.
The same would have applied to your humans. So humans
Yes.
were 85% accurate.
Yes.
ChatGPT was 53% accurate.
And
I'd say that was based on the information you gave it. That might have actually been the correct answer.
arguably, yeah. I'm actually not sure. What Meredith and Simon, were you guys in the same room when these relations were?
Lockdowns.
Yeah, but it's
Ah,
a different procedure, right? So the initial agreement was low, and then we work out the disagreement. So it's, you know, you would imagine that you would have multiple readjustments with ChatGPT as well. That said, of course, if you look at the macro level, and these are really broad distinctions, like taxonomic versus situational. The fact that the performance is still quite low, is a little bit disappointing, and especially if you also look at the literature, there's not a lot of semantic role naming, and that's probably not a coincidence. So there's a really difference in performance for certain types of tasks. Maybe the task that it's been trained on or fine-tuned on, and another type of task, and I feel this falls into the second category.
Yes.
Just to add on to that new piece of information, that the questions were coded during lockdown, so it was like a few years ago, right?
And so, 2 or 3 years ago.
Right, and was the ChatGPT done like in the last month or so?
Leia's, sorry, the one that I did. Yep, I did that. I did that last week actually. Yes.
Yeah. Do you think there might be some time difference? Because I mean, meanings and words and like carried words change over time.
Well,
Do you think that might play a role in this?
of the samples I tested, there weren't really many neologisms. There weren't very many new meanings based on my scan of the sample. Yeah, and so I think of the sample, it was pretty common sense, the relations that I saw personally. Yeah. So yeah, not really. I don't think so.
Thank you so much, everyone, for attending. This is our first session of presentations for the summer scholarship students. And so congratulations, Enzo, Harrison, Daz, and Will. And then the rest of our students will present next week, same time, same place.